Good morning, Year 8. Welcome back to Term 2 and also welcome back to the Mathematics channel, where today we're starting our next new topic, which is probability. All right, some of you may have seen a bit of this in Year 7, some of you may not, so I'm just going to start from scratch so we're all on the same page. Before we do that, here is a quick riddle to warm up your brains. I'm at the beginning of eternity and at the end of time and space. What am I? If you think you know the answer, let's hear it in the comments. First person to guess it correctly will earn my undying respect. For today's lesson, we are looking at an introduction to chance and just the concept of what probability is, really. So if you are choosing to take notes, that should be your heading. Let's get stuck in. All right, first question we're going to think about as a warm-up is that I have a bag, probably should have said jar, but whatever. It contains 15 jelly beans, as you can see here, exactly 15, 9 of which are green. If you picked one out of the bag jar at random, describe the chances of getting a green one. So how would you describe the chances? Some words you could use are certain, you could say impossible, you could say there's an even chance of getting it or not getting it. You could say it's unlikely. For this one, because there is more than half, I'd say there's a pretty decent chance you're going to pull out a green jelly bean. So we'll call this one likely. All right. So that is us describing the chances using the English language. We can get a better answer for this using mathematics. I'm just going to slightly alter the question. So instead of describing the chances, we are finding the probability. Okay, what is the probability? So the probability is going to be a number, a fraction or a decimal or a percentage that's going to mathematically represent the chances of us pulling out a green jelly bean from this 15 jelly bean bag. Okay? So here's how we answer this. This is our notation. This says the probability of us getting a green jelly bean. Okay, it's a bit of a summary. Probability of green in this case would be a 9 in 15 chance. Okay, there's 15 jelly beans, 9 of them are green, so it's a 9 in 15 chance. I hope that makes sense to you. This is a fine answer. It's not very good. We're going to improve it by writing this as a fraction. Okay, so instead of 9 in 15, it's better to write 9 out of 15. Okay, so that is a better answer. There is an even better answer because just like in the fractions topic, it's always good manners to, if you can, simplify your answer. So 9 over 15 we can write as 3 over 5. Okay? So the chances of us getting a green jelly bean are 3 and 5, which means that for every 5 jelly beans you pulled out, you would expect to get 3 green ones. Not necessarily going to happen, but that's what you would expect based on the numbers. Okay? So we can leave our answer as a fraction, or we can instead use a decimal. We can say 0.6 means the exact same thing. Or our third option is we can use a percentage and say there is a 60% chance that we pull out a green jelly bean. Okay, so we'll mostly be using fractions and percentages, but you can use decimals if you prefer. All right, so the key points of today's lesson are that every probability, every fraction in this topic is always going to be between 0 and 1. So our sort of spectrum, our continuum of probability looks like this. It's always going to be between 0 and 1. And 0.5 is smack bang in the middle. All right. If an event, has a probability of 0, it means that it is impossible. Okay, it's 0 out of 15 jelly beans. There is no chance it will ever happen. It's just not possible. Okay. Likewise, up the other end, we have 1, which means certain. Okay, it has to happen. For example, in that last example, if I said you got 15 jelly beans, what's the chances that if you pulled one out, you get a jelly bean? Well, it's going to be 100%. Okay, so impossible to certain. So smack bang in the middle is what we call even chance, 50-50, a coin flip. Okay, it could go one way or the other with an even chance of going either way. All right. So now for the in-between parts, if something is between impossible and even chance, we typically call it unlikely. Okay, if it's less than half a chance, it's unlikely to happen. Whereas if it's above halfway, we say it's likely to happen. Okay. You can be even more specific and say that if you're closer to certain than you are to even chance, so if you're above 0.75, we could call that very likely. And if you're below 0.25, we could say that's very unlikely if you want to be more accurate. Next we need to talk about for our key points is what's called the sample space. So this is a fancy word that's pretty simple. All the sample space means is it is the list of all possible outcomes. Okay, so sample space is just tell me what are all the opportunities, what are the possibilities that can happen essentially, okay? So for an example, if we were rolling just a regular standard six-sided die, the sample space would just be the list of the outcomes, which is just you can get a 1, a 2, etc. up to 6. Okay, we're just listing all the possible outcomes. We use these fancy brackets for sample space because this is called set notation, but that's just showing off. You don't have to do that. So yeah, that's all it is really. Sample space is just list of opportunities, list of possibilities. All right, let's work through an example. So here I have 5 events, and we're not going to find the probabilities. We're just going to describe the chances using our options over here. Okay, from impossible to certain. So I'd like you to pause the video, think about how these 5 events match up with these chances in terms of description, okay? All right, hopefully you've made your choice for the first one, rolling a dice, so like a standard six-sided die, and it shows a 5. Well, because there's only one 5 and there's 6 options, that's pretty unlikely. So we're actually going to say very unlikely, okay? You could say unlikely, but because it's pretty close to impossible, because it's only 1 out of 6 chance, it's definitely closer to impossible than it is to even chance. So very unlikely would be a better answer here, okay? Flipping a coin and it shows heads is obviously going to be even chance. It's a 50-50, could go either way. It is sunny tomorrow. Where I am right now is looking pretty unlikely, but for most days it's sunny, I find. So I'd say being sunny is pretty likely, or just likely. Okay, but that's a bit circumstantial. It's probably a bad question. Option D, you learned something today. Well, on the Mathematics channel, people are learning every single day, and you are no exception. So that's going to be very likely. Although you may be very, very smart, you know this already. So I can't be certain. It's just very likely. And for the last one, you pass your next maths test. That one is definitely impossible for you guys. Not a chance. Nah, just kidding. It's certain. You're going to pass, I promise you. Alright, enough descriptions. Let's actually find some probability using numbers. I'm sick of words. I'm not an English teacher. I'm a maths teacher. Alright, we're going to list some sample spaces. So that means we're going to write out, still more writing, God. We're going to write out our possibilities. Okay, so if I flipped a coin, what are the options? What are the outcomes? Well, it's obviously going to be heads or tails. So there is our sample space, heads and tails. You can write the words or you could just use a letter. Doesn't really bother me. For the next one, if we were rolling 2 dice and adding the numbers together, like if you're playing Monopoly, which some of you could be doing while you're stuck at home. So if you roll 2 dice and you add together the numbers, what are the possibilities? So the smallest you can get would be 2, because that'd be 1 and 1 shown up here. Okay, you can get a 2, you can get a 3 by getting 1 and 2. You can get everything up to the maximum, which would be 6 and 6 makes 12. So here is our sample space. 2 is the smallest option. 12 is the biggest option, and we can get everything in between. For a bonus question today, if you're really switched on, you might be able to let me know in the comments why rolling a 7 on 2 dice is much more likely than rolling a 2. Okay, so even though this sample space has 10 items, they are not all equally likely. In fact, 7 is the most likely. And if you think you know why 7 is most likely, I would love to hear about it in the comments below. Alright, and for the last one, the outcome of a Dragons versus Cronulla match. Well, you might think there's 2 outcomes, either Dragons win or Cronulla lose, but don't forget the teams can tie. So this one has 3 outcomes: the Dragons win, or the Sharks win, or there is a draw between the 2, if it's not a final match, you know. Alright, now we're on to the real numbers. Now we're going to find some probabilities. So we'll start off with 3 kind of easy questions. We'll do some harder ones next. First of all, what is the probability of rolling less than a 5 on a regular die? If you're familiar with probability, you can pause this video and try these first, but if you just want to follow along and learn, that's fine. Alright, rolling a less than a 5, so that's getting a 1, a 2, a 3, or a 4. So we've got 6 options on a regular die. 6 options and 4 of them are less than 5. So our chances, our probability is 4 out of 6. Okay, 1, 2, 3, or 4. Once again, this is a good answer, but you can have a better answer. So this reads probability of less than 5. Okay, this is a good answer. You can have a better answer by simplifying and write 2/3. Okay, so that's good, but that's great. Randomly selecting a letter from the alphabet and it be a vowel. So the vowels are A, E, I, O, and U. There's 5 of those. In the alphabet, there is 26 letters. So if you randomly selected a letter, the chances that it's a vowel would be 5 out of 26. Okay, we're going to be doing lots of questions on decks of cards in this topic. So if you don't play much cards at home, might be a bit of homework for you to play some Go Fish with your siblings or your parents or whoever's at home, because having a good awareness of a deck of cards does come in really useful in this topic. So drawing a heart from a shuffled deck. So heart is one of the 4 suits. There's a few ways you can go about this. You can say, well, I know in a deck of cards there are 52 cards and there are 13 hearts. So you could say there's 13 out of 52. Or if you're a bit cleverer and you want to go to the correct answer straight away, you could say, well, heart is one of the 4 suits. Heart, diamond, spade, and clubs. Okay, so 1 out of the 4 suits, so you get 1 out of 4, which is what 13 out of 52 even simplifies to. So again, they're both the same answer, but the simplified one is the answer that we prefer because it's just better, isn't it? If you are a bit unfamiliar with a deck of cards, don't freak out. We will be doing more work on this later, and hopefully by the end of the topic you'll be more aware. But yeah, if you play a lot of cards, these questions can be pretty easy if you know what's in a deck, in a standard deck, that is. All right, finish off with 3 slightly harder versions of those questions if you're finding these super easy. So this is the pro version of the last 3 questions. Okay. We have the probability of rolling a prime number on a regular die. Let's think. So we've got the 6 numbers, 1, 2, 3, 4, 5, 6. Can you remember A, what prime numbers are, and then B, figure out which out of the 6 are prime numbers? All right, so 5 is a prime number because you can do 1 times 5, and that's the only factors. 6 is not a prime number, it's what's called composite because you can do 6 times 1, and you can also do 2 times 3, so it's got more than 2 factors. Okay. 5 is prime, 5 times 1. 3 is prime, 3 times 1, and so is 2, 2 times 1. The tricky one is that the number 1 is actually not prime because, like I said, prime numbers need 2 factors, and the number 1 only has 1 factor, 1. Okay, so for the first one, if you're really clever, you wouldn't have fallen for the trick, and you would have said, well, out of the 6 numbers on a die, 3 of them are prime, so it's 3 out of 6, which is a half. Okay. All right, now for our next one, we have randomly selecting a consonant, and it isn't M, T, or Q. So in the question on the last slide, we had that there was 26 letters in the alphabet. We said that 5 of them were vowels, and a consonant means not a vowel. Okay, so M, T, or Q are all consonants. If there's 5 vowels, there's 21 consonants, and out of those 21, 18 of them are going to be consonants that aren't M, T, or Q. Okay, so there's 21 in total. There's 18 that aren't these 3. So our probability is 18 out of 21, which can be simplified to 6 out of 7. All right, and for our very last question, we have drawing a joker from a shuffled standard deck of cards. So we got to think to ourselves, in a standard 52 deck of cards, how many of those are jokers? So common answers for this one are 1 out of 52 or 2 out of 52, or some people say 4 out of 52. The correct answer is actually 0. Okay, while you do get jokers in a deck of cards when you buy them, when we're talking about a standard deck of cards, we're talking about only the 4 suits. Okay, there's 13 of each suit, 52 in total, so we don't include the jokers. Okay, so keep in mind, standard deck of cards, no jokers, so we get a probability of 0. And that is a trick question I put in pretty much every probability test. So keep an eye out, I suppose. All right, that'll be it for today. So if that makes sense, you can have a go at the sheet I put on Google Classroom, upload a photo of your work, and I'll be happy. And that's it. Thanks for watching. I hope you learned something. And to finish off today, here is your dank meme. All right, thanks guys. I'll see you next time.